Assalamualaikum and good day. This is a video presentation on Experiment 1, Bernoulli's principle. My name is Safiana bin Ahmad Razali and our group consists of 5 members including Muhammad Rafli Salim bin Hassan, Nabin Kumar anak lelaki Nabi bin Kumar, Muhammad Adi Shazwi bin Ismail, finally Muhammad Eri Iskandar bin Muhammad Saidi. In this video, I will talk about the introduction. In the picture is Daniel Bernoulli, the famous Swiss mathematician who invented Bernoulli's theorem. One of the most significant features is fluid dynamics is the Bernoulli effect. It makes sense conceptually. A fluid traveling along a streamline produces an increase in velocity that is accompanied by corresponding decrease in pressure. Bernoulli's principle governs the internal operations of several fluid-containing devices, including carburetors, and it helps create aerodynamic lift. As in the formula above, refer to the internal and external flow. V stands for velocity of the fluid involved, G is the gravitational force, P stands for the pressure of the fluid, and Z the height of the point. According to Bernoulli's principle, high density fluid will generate more pressure when flowing than low density fluids, since both densities and pressure are inversely proportional. Bernoulli principle often applies to the fluid across the streamline work kinetic energy condition where pressure increases along the streamline. The problem statement in this lab is understanding fluid mechanics is the Bernoulli theorem. It is being used in constructing routine water flow and servo networks, calculating wind loads on buildings, measuring flow of upcoming vehicles that are being used. The theory underlying the equation is essential for technological advancement, intended to enhance the quality of human life. As the objective in this lab, to study the behavior of liquid motion of conserving energy and to experimentally confirm Bernoulli's theorem in different flows. For the scopes, we ensure the air bubbles in multi-manometer is removed before starting the experiment. Water is primarily used in this experiment as a measurable source. That is all from me. Thank you.
Hello and Assalamualaikum. My name is Muhammad Eri Iskandar bin Muhammad Saidi. My metric number is MA19046. So, I will continue present about the chapter 2, which is theory. Okay, first one is Bernoulli principle. Bernoulli principle, formulated by Daniel Bernoulli, state as the speed of a moving fluid increase, the pressure within the fluid decrease. Bernoulli principle is derived from the principle of conservation of energy, where energy cannot be generated or destroyed. Bernoulli equation formula is a relation between pressure, kinetic energy, gravitational potential energy of a fluid in a container. This is the Bernoulli equation, where P1 plus half rho V1 square plus rho GH1 equal to P1 plus half rho V2 square plus rho GH2. Okay, next is how Bernoulli principle derived. Consider the diagram show water flowing along the streamline from left to right. As the outline volume of water enter the constrict region, it speed up. The force from pressure P1 on the left side of the shaded water push to the right and thus positive word since it push in the same direction as the motion of the shaded fluid. The force from pressure P2 on the right side of the shaded fluid push to the left and thus negative word since it push in the opposite direction as the motion of the shaded fluid. We know that the water must speed up due to the continuity equation and therefore have a net positive amount of work done on it. So the work done by the force from pressure on the left side must be larger than the amount of negative work done by the force from pressure on the right side. This means that the pressure on the P1 has to be larger than the pressure on the P2. Okay, we see the principle of continuity. If the fluid is in streamline flow and is incompressible, then we can say that mass of fluid passing through different cross section are equal. That's all from me.
Assalamualaikum and hi, my name is Muhammad Adi Shazwi bin Ismail and my number metric is MA19015. So today I would like to proceed to chapter 3, which is method and procedure. So for this experiment we have two apparatus, which is a hydraulic bench and a Bernoulli principle demonstrator. So a hydraulic bench is a self-contained water supply device that allows recirculating water from a sump tank into a different hydraulic device. A centrifugal pump moves water from the sump tank through a hose into a water inlet at the top of the bench. So for the Bernoulli principle demonstrator is to measure the total pressure head along the test section by positioning it at any section of the duct. So as you can see, experiment procedure, which is A is a ball cock, B is a pump cock, C upper valve manometer, D bottom valve, and E is a single pitot manometer. So first, we need to make sure this B is needed to be open fully. Then A, C, D, and E need to be closed. After that, we can start a pump. So after we start a pump, open slowly A to expel air in a manometer, then close it back when the air is completely expelled. Then we can stop the pump once they have a desired reading and result. So after that, air should be open to a position that could only enable a little flow through, while C need to be open partially to enable air to get into a manometer, and then air needed to be open fully. When the pump is started, water will automatically try to go up a manometer but not expel from the C. So then we can D need to be open slowly to half position to allow water flow through. Then C and E should be open fully. Then we can take all the readings such as a static head position and measure total pressure at a specific location in the inventory. After that, D is needed to be moved into two additional locations to change the flow rate. And lastly, repeat from 10.10 till all data is collected.
Good day everyone, my name is Kavin Kumar and my ID number is MA19020. So today I would like to give a talk on the chapter 4, the lab, which is involved the result graphs and the discussion of the lab. As the first thing, we have managed to take the static head reading and the static Python head result of the experiment, which consists of 6 different H, and the H stands for the 6 different positions in the venturimeter. So 6 of them having a different space area. And the next one is the table of inner diameter and the area of the Bernoulli principle apparatus we have used, which is the venturimeter. So the following one is the reading of the head total, head dynamic, and head static, and the velocity calculated with the formula along the velocity measured during the lab time. After getting the S dynamic and S static, we managed to plot a graph with the different position as well. So the table 1 shows the S dynamic versus the location, and the table 2 shows the S static with the location as well. And the following is the V measurement and V calculation was plotted against the position of the venturimeter. As we can see in the both graph, it is clearly known that the true value and the measured value is nearest. Next, I would like to give an explanation on the discussion part. As the first question, why there is a difference between V measure and V calculation? As we know, there are small changes from the graph itself between the V measurement and V calculation because of the parallax error that could be occurred during our lab time. So what are basically parallax error? So parallax error, which is the reading can be verified differently whenever we're taking the reading during the lab time, which is the position of the eye is not parallel towards the meniscus of the venturimeter. Okay, next is what is the conclusion can be made from the variation of static head and dynamic head throughout the 6 different positions as I explained before. So as from the calculation made, it can clearly note that the pressure drops as the pipe area decrease in 6 position. This is because it is happened according to the equation of P equal to FOA. So the area, as the area decreases, the pressure will be decreasing too. The next one is what conclusion can be made after finding static head and the dynamic head. Okay, to be stated clearly, static is something whenever we calculating whenever the fluid is in motionless, and dynamic is something that we are calculating when the fluid is undergoing some movement as well. So other than this, the friction head loss is considered whenever calculating the both dynamic and static head, because the internal friction will affect the movement of the fluid as well. As we know, the formula for the total dynamic head is elevation head plus friction head loss plus with the pressure head. And the following, we have advised to came up with the CFD analysis for the one of the experiment we are doing. So our team decided to came up with the CFD analysis for the Bernoulli principle. So there are several important steps in order to do the CFD analysis. So the first step is in order to came up with the sketch and the drawing as per the dimension. And the next one is the applying the boundary condition to the venturimeter, which is the inlet, outlet, and the boundary as well. The next one is applying the final mesh in order to calculate the result and the calculation as well. So final mesh are advisable to be taken out, because the smaller the mesh, the easier the result will be able to come out. And finally, this is the desired result we have gotten from the CFD analysis. So the red color indicates that the particular area is having a high pressure, whereas the blue stands for lower static pressure in the particular area. So the reason on the static pressure is low because the area of the position is smaller in size, or dust or any minute particles may be clogged in the region and reduce the movement of the fluid. So as we can see the figure, we can know that the red stands for the bigger area, which is from the left and right side, the middle part, which is the smaller size, having the lower pressure, static pressure. So that's all from me. Thank you.
Assalamualaikum and a very good day, Dr. Annie and fellow audience. I am Muhammad Rafi Salim bin Hassan Raza, MA 18178. Today I'm going to present our group conclusion on Fluid Mechanics Lab Bernoulli Principle Experiment. There is 6 major conclusions based on our finding from this experiment that we would like to share. In a nutshell, it has been understood that the relationship between pressure and velocity for fluid moving through a tube has been understood. When the pressure was low, the fluid level was high, and when the pressure was high, the fluid level was also high. The velocity decreased significantly in relation to the pressure when the pressure was high. Investigation on the impact of cross-section area on pressure and velocity are possible. While area and resistance are indirectly related, there is an inverse relationship between area and velocity. Although some energy was lost owing to friction, it was essentially constant, as we discovered. By ignoring all these findings, we may conclude that Bernoulli theorem is true. Other than that, experiment objectives are achieved as the Bernoulli principle is understood and applied. We also get to know that the speed of water is indirectly proportional to the area of each segment. Other than that, it was known that experiment results were quite different from calculated value using the Bernoulli formula, as some random errors should be avoided during the experiment time, such as parallax error. Moreover, as we requested to come with the CFD process with the lab, we all learned that and understood the proper 3 stages need to be done before the analysis is stage pre-processing, solver, and post-processing. That's all from me. Thank you.